And let's go back up there. And we're on page 290, exercise 5.5, terminating and non-terminating decimals. Well, problem number 2 says 3 over 10. So I just get my little calculator and I go 3 and I hit divide by 10. And I get 0.3. Now, is that a terminating decimal or a non-terminating decimal?
Non-terminating?
Did it stop or did it not stop?
It stopped.
It stopped. So if it comes out and stops, that means it's terminating. Oh, that's back on page. What page is that? 284. That's on page 284. So if it stops, it's terminating. If it just keeps going, it's non-terminating. You go, what? Okay, it either stops or it repeats and just goes on and on and on. If it stops, it's terminating. If it just goes on and on and on, it's non-terminating or repeating. So just write that in your notes so you can keep it straight. Number 4, 27 over 10. You divide 27 by 10, you get 2.7. What did it do? Sometimes we say it came out even. Don't we say that? So that's another way to look at it. So that's a terminating number. What are we supposed to do here? Oh, just write it in decimal form. Okay, number 6, 38 over 100. 38 divided by 100 comes out to be, just take your calculator, 0.38. You can't do these in your head. You have to have a little calculator, or use your telephone, or go to the internet and type in calculator, and guess what you'll find? A little calculator that'll do all this stuff for you. Number 8, 3520 divided by 100 is 35.2. Number 10, 143 divided by 1,000 is 0.143. Number 12, 25,360 divided by 1,000 is 25.36. Number 14, 7 over 8. 7 divided by 8 is 0.875. Looks like, see on my little screen, it just stopped. So it came out even, so to speak. It's terminating decimal. 15 divided by 32, what happened there? Divided by 32. I still have space to the left on my screen, so I know it just stopped again. That's terminating. 18, 20, 7 divided by 6. And it fills the whole screen up, and it just has 6, 6, 6, 6, 6, 6, 6. Does anyone know what would happen if I had a longer screen on my little calculator?
Keep on saying 6.
It would just keep on going. So that would be, it doesn't terminate. That's non-terminating, or it's a repeating decimal. So how do I say that? Oh, isn't this so beautiful? Math is so beautiful. Instead of just writing 6, now I should have done that. Just take this thing and scroll it over and go 6, 6, 6, 6, 6, and just scroll it over 6, 6, 6, 6, 6. But instead, I just write, no, let's use blue. I like that today. Well, I was on blue. I just write 1.16 with a line over the 6, which says the 6 repeats. Isn't that cool? Number 22. Oops, now we're doing these mixed numbers. 6 and 1/4 would be what? See how I did that the other day? 1, 2, 3, 4, 5, 6. and then 1/4. So that would be 4, 4, 4, 4, 4 fourths. What is that? 24, and one more would be 25/4. I have 25 fourths here if I count them all up. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19, 20, 21, 22, 23, 24, and 25. Or you can take 4 times 6, get 24, and add the 1. You get 25/4. So now I divide 25, because I'm supposed to change it to a decimal, divided by 4 is 6.25. Okay? Number 24. 3 2/3. 3 times 3 is 9, plus 2, 11/3. 11 divided by 3. There we go again. So what's the answer? 3.6 with a line over the 6. See what I'm doing? I just put a line over the stuff that repeats. Number 26, 3/14. Now, how do I know it does not terminate? I take 3, I divide by 14, and it fills the screen up, but I don't see anything repeating. You follow me? So I take what's on my screen, and I go 2.142857, then I take that times 14, and I don't get 3. I get 2.99999. So that means this thing did not terminate. Because up here, where it did terminate, if I take 6.25 times 4, I'm going to get 25. So that's how you can check it out if your calculator doesn't go far enough to find out what's going on. And in this case, this is interesting. On my screen, when I multiplied those two, it said 2.9999998. It didn't keep going. So this is not terminating. And it's not repeating. But all they want you to say is it terminating or non-terminating? Number 28. Another one that doesn't terminate. Except, now see, this is what's scary about this stuff. 4/28 reduces down to 1/7. Is that right? Mm-hmm. Okay, 1/7 repeats. You go, how do you know that? I've just messed with it long enough to where I know that. So what happens is here I say it doesn't terminate, but it doesn't just go on and on and on either. It actually becomes this 142857, and I think it starts out 1, then it goes, if you had a screen that went far enough, it would go 1, 4. Let me erase this. 1, 4, 2, 8, 5, 7, 1, 4. See what's going on? The 142857 repeats itself over and over again. So I would just put a line over it like that if I wanted to show that it was a repeating decimal. All right, number 30. What are we doing here? 9 over 250. I took 9 divided by 250. I get 0.036. Is that what I got? 9 divided by 250. 0.036. 0.036. That's terminating. And is that all they want me doing? Sure enough. Now we come to problems 31 through 42, and it says rewrite each repeating decimal using a bar and as few digits as possible. So number 32, you see what I've done for number 32? The 7 repeats, so I just put 0.7 with a bar over the 7. And you say, is that the same as saying 0.7777777 dot 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 dot? And the answer is yes. So do you see how you'd work every one of these? What repeats for number 34? 73. What repeats for number 36?
930.
930. What repeats for number 38?
2.
So now see, I just put a line over the 2 because that's all that repeats. What repeats for number 40? 2, 3, 5, 1, 5, 1, 5, 1, dot, dot, dot. The 5, 1. Everybody follow what's going on? What repeats for number 42? 9.233737. Well, does 73 or 37 repeat?
7.
But could I also back up and say 37 repeats? So, and they see, and the instruction said with as few digits as possible. I mean, if you would have written that out and said that, if you would have said this, 9.23373. Do you understand that those two numbers say the exact same thing? Because this one says you repeat 37, and this one says you repeat 73. You see how they're the same number? But since they said with the fewest number of digits, we'll use this one here as our answer. Number 44, write each number as a fraction. And in case you didn't know, a fraction is the quotient of two integers. And then reduce it if you can. Oh, you're not going to like these. I've never met anybody who did. Look how I show my work for number 44. Okay, can you see for number 44 it has one thing that repeats? So since it has one thing that repeats, I go 10 times the number, would be 6.666. See number 44? Says 0.6. If I take that times 10, I get 6.6666 dot dot dot. You follow me? Okay, why do you do that? I'll show you. Now I take 1 times the number, which is just the number, 0.66666. Now I subtract those two. What's 6.6666666 minus 0.6666666?
6, wouldn't
6. Yeah. See how I got rid of all the stuff that repeats? By doing this little subtraction thing. And what's 10 minus 1? 9. So 9x equals 6. What would x equal? 6 divided by 9. Or reduced down 2/3. Did I just teach you a new mathematical magic trick? When you see a repeating number, you can change it to a decimal by doing this little process, or you can change it to a fraction by doing this little process here. Okay? Let's do another one. 46 says 0.21 repeats. You see that? So I have two digits, so I take the number times 100, and that gives me 21.212121. And then I have the number, 1 times the number is just the number, 0.21. Then I subtract those two and end up with all of this stuff zeros out. 0, 0, 0, 0, 0, 0, 0, 0. And I'm left with 21. And 100 minus 1 is 99. So what's my fraction? 21 over 99, which reduces down to 7 over 33. So I just took, here's what I just did. I just took this number, 0.21, which one is this, number 46? I just took this number, 0.21, with a line over the 21, and said that equals 7 over 33. Actually, let's make it equal something else. That equals 21 over, I hate it when I show people shortcuts, because then they just use the shortcut without thinking about what's going on. But that's just 21 over 99, which reduces down to 7 over 33. So when I come to 48, 48 says 0.102 with a line over it. And I know when I jump through all these hoops, since 3 things repeat, I want 3 zeros, so I'm going to take it times 1,000. Then I'm going to subtract 1, and I'm going to get 999 of them equal 102. You follow the process that I've been doing the same process. So I just come over here and go, so 102 with a line over it equals 102 over what? 999. And then I can reduce that by, divide by 3, 34 over 333. Am I done with that? Well, I could take this, what, 2 times 17. Can I divide 333? I know I can't divide by 2. Can I divide it by 17? $333 divided by 17. Nope. I mean, I came out with a decimal, so it doesn't come out even. So I'm saying this is in simplified form right there. Do you follow this shortcut that I'm using here? See how every time I do the math over here, when one thing repeats, I end up with 9 underneath. When 2 things repeat, I end up with 99. When 3 things repeat, I end up with 999. I see a pattern. So that means I just take the stuff that repeats. Uh-oh. See, I think I found a shortcut, and then the guy who wrote the book throws me a zinger. Number 50. See what he did for number 50? 3 things repeat, so I'm going to use 1,000. But now he had a number in front of it, didn't he? See, he had written for number 50, he had 5.672 with this repeating. So now I'm stuck to go back to my old way of doing it. 1,000 times that would be this number, minus 1 would be 999 of these, equals 5,667. So it's 5,667 over 999. Can I reduce that down? I don't know. I didn't keep working it out. But you know what? Okay. Now I don't know if I'm gonna if this just confuses you, just forget about it. But say, you know what I could say? This is 5 and 672 over 999. You see that? I can make a mixed number out of it. And then I could simplify this part and either leave my answer as a mixed number or change it to an improper fraction.
The most reduced that we can get is 1,889 over 333.
What happens?
1,889 over 333.
That's lowest terms.
Yes.
So all this messing around with trees didn't do me any good, did it? That's as far as you can go with it. And if you divide 1,889 divided by 333, you will get 5 point. This equals 5.672672 and then it stopped. That's where my screen stops, so I just know that it's that, right? Or 5.672 with a line over it. Number 54. What are we doing here? 2.48. And one thing repeats. So again, I could come over here and go 2. Which one is this? 50 what? 54. 2 point. That's getting messy now, isn't it? Because only the 8 repeats. So I better just stick with the old method. 10 times the number is 24.888. 1 times the number is 2.4. You know what? I might just change that. Well, okay, we can leave it like that. Because then when we subtract, I'm going to get 9 of these equals 22.4. So that means I have the number is 22.4 over 9, which would be 224 over 90. See, I do that to get rid of the decimal point. I move this over and add a 0 down here. So once you've done a few of these, he just kind of messes with you a little bit, but you're following the same technique over and over again. And then that reduces down to 112 over 45. Number 56. Same thing again. He gives you 2 things that repeat, so I use 100. Then I come up with 99 equals 22.92. So now I have 22.92 over 99, which would be 2292, move it over 2 places, over 9,900, 9,900. Number 60. Write each percent as a decimal. Were you taught that percent equals per hundred? Were you taught that anywhere? I mean, look at a percent sign. It's a zero, a slash, and another zero, right? That looks like 100 to me. Someone just messed with it. So percent means per hundred. So 23.4% means 23.4 over 100, which would be 234 over 1,000, which would be 0.234. Now, I did all of this so you could understand what's going on. You probably weren't taught this strung out technique to make sense out of it because you've told me in the past, by the looks on your faces, you don't like fractions. And this is why they are my friends, because they help me understand what's going on. You were just probably taught, move the decimal point 2 places to the left and drop the percent sign. And that's why that works. Because when I move it 2 places to the left and drop the percent sign, I end up with 0.234. But this is why that little shortcut works. So I don't mind. I mean, I just taught you a shortcut because we have so many problems to work here. So I don't mind you using a shortcut. But doesn't it help when you understand why the shortcut works? Number 62. 56.9% would be 56.9 over 100, which would be 569 over 1,000, which would be 0.569. Or move it 2 places over, and it's 0.569. There you go. 64. Oh, let's just move it over 2 places and be done with it. 0.08. Oh no. The decimal point wasn't there. It's over here, right? If I'm going to move it 2 places, where did I go? No, point what? 1, 2, 3, 4, point 1, 2, 3, 4, and then 8. Because see, my decimal point was here, so I had 8 thousandths of a percent. That's 8 thousandths of 100th. That would be like taking 8 thousandths of means times 100th, and that would give you what? 8 over 1 with 5 zeros, which is 8 over 100,000. My friends, the fractions, help me see what's going on. Number 66. 93.56%, there's the decimal point. Move it over 2 places, equals 0.9356. And when you're showing your work, okay, you say, I don't want to mess with all these fractions. Okay, I just showed my work by taking this little blue line and moving the decimal point 2 places and dropping the percent sign. You follow me? I'm showing my work that way. Number 68. Write each decimal as a percent. Okay, if a percent to a decimal moves it to the left, then what would I do to change this to a percent? Move it to the right, and it becomes 38%. You follow that? If you want to see an explanation, 0.38 is 38 over 100. Percent means per 100, so that would be 38 per 100. So it's 38%. In other words, you can take any decimal and write it as a fraction with a denominator of 100, and the numerator will be your percent. Number 70. What happened there? 9.998. And I move it where? 2 places to the right, and it becomes 999.8%. You go, I don't think I like that one. If that's on a multiple choice test, he'll probably give you another answer that makes you feel warm and fuzzy, and you'll mark it and miss it. So say, okay, so that's like 9998 over 1,000. 3 decimal places would be 1,000. So that's like 999.8, put a decimal point here, over 100. So that would be 999.8%. So fractions help me avoid driving in the ditch. Number 72, 0.00452, that would be 0.452%. Number, just move it 2 places. When you're going from percent to decimal, you're moving it to the left. When you're going from decimals to percent, you're moving it to the right. You probably ought to write yourself a note. I mean, you say, well, I know that. I know you know it. But do you understand? When it comes test time and we do a whole bunch of this stuff all at once, your brain starts to turn into jello. So if you have some notes to look at to remind you as to what the rules are, it'll help you keep your thinking straight. And then if you could look at a note once in a while, it also puts your mind at ease so it doesn't get so stressed about trying to find all the information I need to work this problem. You go, hey, it's there on the note, relax. Don't get so stressed. Then you'll be less apt to make a mistake. You've heard people say that. You're driving on ice. The more tense you are, the more likely you are to have an accident. The more tense you are with math, the more likely you are to make a mistake. Well, all this rain's messing with my allergies, isn't it? So be it. Number 78. Oh, yeah. 4/7 to 1 decimal place. So I just take 4 and divide by 7, and I get, whoa, I get this big old number here. But what they say to do? Write it as a percent to 1 decimal place. So to make it a percent, I move the decimal point 2 places to the right. Is that right? Am I going the right direction? Yeah? 2 places to the right. But, so that would be 57. But they want me to show it to 1 decimal place. So I look at the next place here, the 1, and do I leave it 1 or make it 2? And the 4 tells me I do what? I leave it at 57.1%. That's my answer. So they want, because they want me to change it to a percent. Well, the percent would be the percent, if I just change it to a percent, that would be 57.14285%. You follow me? But then they want me to the 1 decimal place. So I want to go out this far. So do I leave it 57.1 or make it 57.2? And the 4 tells me I leave it at 57.1. 80. 7 over 8. 7 divided by 8. 0.875. So to change that to a percent, I move it over 2 places. 87.5 to 1 decimal place. That would be the correct answer right there. Number 82. Hey, I don't know if anybody ever taught you this. I remember when I was taught how to do percent problems like this, these little problems, like 81 and 82 and 83 and 84. I was taught like you use this technique for this kind and this technique for this kind. And it's like, so they're giving me 3 or 4 ways to do these things, but I couldn't remember which way I was supposed to work each one of them. I said, I just need one simple, straightforward way to work them all. So guess what? I just translate from English to math. And number 82 says, what? What? That's my empty box. Is, that's equals, what is 110% of 90? See how I went from all those words to a math picture with an empty box in it? And if I have an empty box, then my mind is saying, what goes in the empty box? And what does of mean? If I have 3 dozen of these boiled eggs that we're going to make for Easter eggs, how many eggs do I have? Because of means multiply. So write that in your notes. Of means multiply. But see, no one taught you how to multiply with percents. You learn how to multiply with whole numbers, fractions, and decimals. But they don't teach you how to multiply with percents, because when it comes to percents, you convert the percents back to decimals. So I move it over here and I get 1.10 times 90. What's 1.10? 1.10 times 90. 99. So guess what goes in my empty box? 99 is 110% of 90. Is that okay with everybody? 100% of 90 would be 90, right? 10% of 90 would be 9. So 110% would be 90 plus 9. Let's do another one. 84. 15, so I write down 15 is, that's equals 30% of empty box. What number? So I go 15 equals 30% is 0.30. Remember, change it to a decimal. Of means times. So now I have 15 equals 0.30 times something. How would I find this something? Well, watch. If 6 equals 2 times something, what would go in the empty box to make a true statement? 3. I mean, can all of you see that? See, I make up a little problem that's easy for me to see. So how do I find 3? So I go 3 equals 6 divided by 2. You see that? In other words, to undo, maybe you were taught to do this somewhere. To undo multiplication, I go 6 divided by 2 will equal the empty box. I don't know why I wrote 12 before. When I did it in red, let's get that out of there. That's too much. That's too much to think about. Let's just use little numbers like 6. So, 15 divided by 0.30 is going to equal the empty box. Well, I'm going to need my calculator for that one. 15 divided by 0.30 equals 50. So what goes in the empty box? 50. And I'll just tell you right now, my own little heart flutters and says, that doesn't seem right. And if I was taking a multiple choice test, I might be tempted to look for another answer that I feel better about. So watch what I do to check this out. I'm going, 50? That's 50? I don't think so. Say, well, check it out. What's 50 times what? 0.30. Whoops, had to turn it on. What's 50 times 0.30? 15. Ha! I got the original problem. So now my heart feels better about this whole thing. I just checked it out to make sure I wouldn't pick the wrong answer when I'm looking at multiple choice answers. Number 86. Find 12.5% of 320. So, if I want to find it, then I go 12.5% of 320 is empty box. See that? Is something. Then I change 12.5% to 0.1225. You go, how'd you get that? Well, isn't 1/4 0.25? So that would be, so that makes this point, or that's 12.25%. So I move it 2 places over, it's 0.1225. 1/4, let me put that back up there again, equals 0.25. 1 divided by 4. So I have 0.1225 times 320, and that'll be my empty box. 0.1225 times 320 equals 39.2. Looks good to me. Number 88. One of the most expensive British standard cars is a Rolls-Royce Phantom 6. And it costs $312,940. If you want to armor plate it, because if you drive one of those, someone might want to kidnap you, it'll cost you $560,000. Is that to armor plate it on top of the 312, or is that to order it from the factory armor plated? An armor plated version was quoted at $560,000. So I can order it without armor plate for $312,000, or I can order it armor plated for $560,000. What do they want to know? What percent more does the armor plated version cost? Now, I was always taught to do this. How much more is the armor plated version? So I subtract 312 from 560 and I get 247,000. So it's 247,000 more than the plain version. So I was taught to take 247,000 is what percent of the 312,000? That's the way I was taught to do these things. Is do that subtraction to find how much more you're paying, and then find out what percent that is of whatever they're asking for. And they're asking for what percent is that of the original cost, aren't they? Yeah. What percent is that of the original cost? And then when I get through doing that, I come up with 78.94%. So you can buy an original version and add to the price 78.94%, and you'll end up with an armored version. And if I want to check it out, I take get that out of here. I take 0.7894 times 312,954, and I get 247,045,88 or 046. So I get this. So I multiply these two numbers, and I come back and I get this number back again. So I know I've done my math right. But later in life, someone taught me a shortcut that said, look, just take the original number. 560 is what the armor per invasion cost, and that is what percent of the 312. Even though that's not what they're asking. And you say, well, and when I do that, 560 comes out to be 1.78 times 312. Oh, I have to work that out here, don't I? That would be 5600 equals something times 312, 954. So the something would equal 560,000 divided by 312, 954. And that comes out to be 1.7894. But look at this. That's the whole, one is the whole cost of the car plus 7894. So I can look at this and just drop the 1 and say there's my 7894, which becomes, move it over, 78.94%. So you pick whichever method works for you. And if you don't like either one of them, then just go ahead and find another one and work it on your own. Number 90, how we doing? We're okay. Number 90 says refer to problem 89. How many pounds of bone does a person have? What does 89 say? Bone is what? Bone is 17.5% of your weight, right? And this person weighs 150 pounds, so I change the percent to a decimal, 0.175. Of means times 150 equals 26.25 pounds. So I've done the first part. How many pounds of organs does the person have? So what are organs? 6.5%. 6.5% of 150. That would be, move it over 2 places, 0.065 times 150. What would that equal? 0.065 times 150. 9 0.75 pounds. That's how many organs, how much you're packing around in organs. Well, that's not bad. You go, well, if that's how much is organs and that's how much is bone, and 43% is muscle and 6% is skin, what's the rest of it? What's 43 and 26? 69. And 76 and 82. That's 100%. That's not 100% of my weight. My doctor says there's a bunch of stuff accumulated around my muscles and organs and bones. Maybe that's why the guy weighs 150 pounds. All right. Number 92. This is pretty cool. Stop when you get to where? Whoa. We got to do some of these over here. Percent increase and decrease. I need to do a couple of those for you. So let's turn over to number 106. If you want all these practice problems that I've got worked out here, send me an email and say, can you send me actually, if I've already sent it to you, you can go tap on this one and look at all those practice problems. But 106, if 25 is increased to 30, that's 105. If 32 is decreased to 28, that means 32 minus 28, that would be 4, right? So 4 is the amount of decrease, but they don't want to know the amount of decrease. They want to know what? The percent of decrease. Okay, so that means I want to know 4 is what percent? Do it this way. 4 is what percent of, now I have two choices that I can put there. 32 or 28. And they want to know the amount of decrease. So which number do I put here? 32 or 28? Where did I start?
32.
32. So that's the number that goes there. Because I started here and decreased. So 4 is what percent of 32? So that means to find the percent, I put 4 over 32 equals the empty box. So it comes out to be 12.5%. Well, this divided gives you 0.125, then change it to a percent, move it over 2 places. So when you're working these, like 108, if you decrease 24 by 16.5%, what's the result? Then that would be 24 decreased by this much. 16.5% of what? Of 24. And what is that? 3.96. Subtract that from 24 and you get 20.04. Number 110. Felicia received a raise. So her raise was $1,750. Her salary was $25,000 before the raise. What percent raise did she receive? So how would you find the percent? The amount of the raise, $17,000 $500 divided by her original salary. And you get a 7% raise. To check it out, take 7 or take 0.07 times her salary, 25,000, and sure enough, I get 1,750. I get the amount of her raise. So you can always check it out to see what's going on. Okay, where do you stop? Stop at 115. Problem 115. And if you get hung up on some of these, just relax. Come to class a little early on Monday. And I'm usually here by 7:30. I'll answer your questions and help you get it done. Have a nice weekend.